Hi there and thank you for joining me. In this video we are taking a walkthrough of paper 3 of the Pearson Edexcel Foundation GCSE Maths paper, originally written for June 2020. So let's make a start with question 1. It is asking us to change 300 centimetres into metres. We simply need to know that there are 100 centimetres in a metre, so 100 centimetres equals 1 metre. Therefore, this question has 300 centimetres, so the answer is 3 metres. Question 2, work out 1/3 of 24. The way we work out a third of something is to divide it by 3. How many 3's are there in 24? There are 8, so a third of 24 is 8. Question 3 is asking us to write 40% as a fraction. Well, it's always worth remembering that if you have any percentage, you can turn it into a fraction simply by writing it over 100. So 40% is 40 hundredths. Now, it doesn't tell us to do this, but a good idea in a question like this is to always simplify. So if we divide the top and the bottom by 10, we would get 4 over 10. And if we divide the top and bottom by 2, we get 2 over 5. So the answer is 2/5. Question 4. Work out 2.5 squared. Well, squared simply means multiplied by itself. So if you prefer to do this pen and paper, it's 2.5 times 2.5. Don't forget though, this is a calculator paper, so the simple answer is 6.25. Question 5 is asking us to write the following numbers in order of size, starting with the smallest number. If this is the kind of question that confuses you a little bit, don't forget you can mock up a little number line here and imagine a thermometer. If a thermometer has 0, it then has 1 and 2 and 3 going up. But it also has -1, -2, -3. So the numbers get smaller as we go down. So effectively, the larger the minus, the larger the digit on the minus here, the smaller the number. So the first number we are looking at as the smallest number is -6. Then we are looking at -4. Then -3. There are no more minuses, so the next one is 0. And then we carry up numerically 1, followed by 2, followed finally by 7. In question 6, we were asked to extract some information from the graph that we're given here. A quick look, it's about car production in millions. We have the millions up the side and the years 1 to 8 and bars. So, question 6a says, for how many of these years was car production more than 1.4 million? Well, 1.4 million is here on the graph, so we can draw a line straight through it if you like. And if we look at how many years, it's more than, well, it's 1, 2, 3, 4, 5 years. So our answer is 5 here. And then we are asked, in which 2 years was car production the same? Well, it's 1.5 million in years 5 and 6. So 5 and 6 are the answers. Question 7. We've got a square here with smaller squares in the centre. It says what fraction of the shape is shaded. First of all, let's take a look at how many small squares there are. It's 1, 2, 3, 4 by 1, 2, 3, 4. So there are 16 squares altogether. How many are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the fraction is 12 out of 16. But in this question, it does say give your answer in its simplest form. We need to divide the top and bottom by a common number. They will both divide by 4 and we get the answer 3/4. Moving on to question 8, and Karim is buying 200 tiles. He's buying them in boxes. There are 25 tiles in each box. We know that each box of tiles costs £9.75 and we want to work out the total cost of boxes. Well, he's buying 200, but he's buying them in boxes and we know there are 25 tiles in each box. We need to know how many boxes. So that will be done with 200 divided by 25. Again, don't forget this is a calculator question, so on your calculator 200 divided by 25 is 8. So there are 8 boxes. Each box is £9.75. So the second calculation is 8 multiplied by 9.75, and the answer is 78. So £78. Question 9 is in 3 parts. Part A, work out the value of 300 divided by 2 times 5. Well, to work out what we are dividing 300 for, we need to do 2 times 5. So that's 300 divided by 10. And 300 divided by 10 is 30. Part B wants us to work out the value, and we've got 2 sets of brackets with numbers inside them. So what we are doing is multiplying the 2 brackets together. But before we can do that, we need to work out the value of each bracket. So in this bracket we have 6 minus 2.5. Well, that gives us an answer 3.5. In the other bracket, which we want to multiply by, we have 8 plus 4, so that is 12. So our calculation is 3.5 times 12, which is going to be 42. And part C, write down the reciprocal of 20. Well, possibly the easiest way to describe a reciprocal is to turn a number upside down. So the reciprocal of 20 is 1 over 20. Question 10 is another question where we're asked to take information from a graph. This time it's showing information about the time in minutes that a liquid has been cooling. So we have a liquid that started out at 100 degrees, and as time in minutes go by, the temperature is cooling down. 2 parts. Part A says, what is the temperature of the liquid at time 2 minutes? So, as accurately as you can, find 2 minutes along the bottom axis here. 2 is here. Take a line up to the curve and then read across from where you've met the line, and at 2 minutes the temperature was 80 degrees. So your answer to part A is 80. We do a similar thing but in the opposite direction for part B. It says Pam recorded the time when the liquid had a temperature of 50. So now we're looking for a temperature of 50 here. This time we're going to draw the line in this direction until we meet the line. Again, be as accurate as you can, and if we bring it down we see that 50 was after 8 minutes. So 8 minutes is our answer. And in fact, on the next page there's part C to question 10. So Pam says the temperature of the liquid drops more in the first 3 minutes of cooling than it does between the 9 and 12 minute slots. Well, there are a couple of ways you can answer this. Let's go back to the graph here. The simplest answer, if we look at the first 3 minutes here, so we are looking between 0 and 3, and we are comparing it between 9 and 12. Now you could work out the temperatures. You could point out that it started at 100 and after 3 minutes it's dropped down to about 72 and work that out. And then you could say that in the last 3 minutes, well, at 9 minutes here it's somewhere about 48 and it's dropped down to 40. So you can actually work out the drops. But actually a simpler answer is to say yes, we can tell it has dropped more because the curve is steeper in the first 3 minutes than it is in the last 3. Either answer is good. In question 11 we're being given a quadrilateral. PQRS pictured here, PST on the bottom is a straight line, and we're asked to find the angle at Y. A couple of things we need to know about angles, and it's always a good idea to write down what you know. So firstly, angles in a quadrilateral add up to 360 degrees. So in this quadrilateral we already have 130 and 65 and 95. So if we add those up, we end up with 290 degrees. So if the 4 angles add up to 360, that means that 360 minus 290 means the other angle inside the quadrilateral, the angle here, must be 70. Then we've got our second rule, and that is that angles on a straight line add up to 180. So the two angles here, 70 and y, add up to 180. Therefore, 180 minus 70 gives us an angle of 110 degrees. Question 12a has two subparts, so we'll do these together. It's about number sequences. So here are the first 5 terms of a number sequence, 45, 40, 35, and so on. Write down the next 2 terms. Well, we have to have a look at what the term is doing. It is going down, and it is going down in 5s. So if we continue subtracting 5, the next term would be 20, and the next one would be 15. So those are your answers to the first part of A. It then said a term of this sequence is minus 5, and it wants to know which term. Well, you could work out the expression for this sequence and do it that way, but let's take a simple look at this. We want to know where minus 5 is. Let's keep going. The next number down would be, and I'll start down here, if we go from 15, the next number would be 10. Then we would go down to 5, then it would be 0, and then it would be minus 5. So we want to know what the number is. Well, 45 was the first term, second, third, fourth, 5th, 6th, 7th, 8th, 9th, 10th. It's the 11th term in that sequence. We simply count on, knowing that the first number is term number 1. So it's the 11th number. Moving on to part B of question 12. This is asking us about a different sequence. It says the nth term is given by the expression 4n plus 3. Now don't forget, the n stands for the number of the term. Therefore, when we're asked to find the 9th term, it simply means that the 9 substitutes for the n. So we get 4 times 9 plus 3. 4 times 9 is 36, so that gives us 36 plus 3 equals 39. Question 13, work out the perimeter of this shape. So we have a kind of L shape, and we are given most of the lengths of the sides. Don't forget, perimeter is the outside edge. A couple of sides missing that we need to work out first. Well, this one here, if the bottom is 10 and the top here is only 4, then to make up the rest, this part must be 6. And using similar maths, if the height of the whole shape is 7 on the left hand side here, this side down here is only 5, so to make up the difference, this side here must be 2. Therefore, we've now got all our sides, so 7 plus 4 is 11, plus 5 is 16, plus 6 is 22, plus 2 is 24, plus 10 is 34 centimetres. Question 14 is our first dip into algebra for this paper, and part A says simplify 3x plus 5y plus 2x minus 4y. We are collecting like terms. So first of all, let's look at the x's. We have a 3x, which is a positive, and we have plus 2x. So quite simply, 3 plus 2 is 5. Therefore, altogether, we have 5x's. Let's have a look at the y's. We have 5y's, that is a plus, so 5y minus 4y. So 5 minus 4 gives us 1, so it's plus 1y, which we simply write as y. Moving on to part B, we're asked to solve a little equation. 5p plus 7 equals 22. A couple of ways to do this. I always solve these problems by rearranging the formula. So the first thing I'm going to do is take that 7 and move it to the side. Knowing that it's a plus on this side, it becomes a minus on the other. So I get 5p equals 22 minus 7. Therefore 5p equals 22 minus 7 is 15. I'm then going to move the 5 to the other side. At the moment, that 5 is a multiplier. If I move it to the other side, it becomes a divider. So I end up with p is 15 divided by 5. And 15 divided by 5 is 3. Question 15, a very typical question where we are looking to buy something and we have two different options as to how we do it. So Harry's wanting to buy at least 30 batteries. He assumes he has to buy batteries in whole packs. He wants to buy the batteries as cheaply as possible from the same shop. Which shop should he buy the batteries from, A or B? Let's have a look at this. He wants to buy at least 30. Now in shop A, they sell batteries in packs of 4. So using his assumption that he has to buy batteries in whole packs, 30 batteries divided by 4, well, that works out at 7.5 packs. He can't do that. He has to buy whole packs, so he would have to buy 8 packs. So our calculation is 8 times £1.60. Now that is going to give us £12.80. In shop B, he can buy them in packs of 6. Now this works better because 30 divided by 6 means he has to buy 5 packs. He's going to buy 5 packs and each pack is £2.70, giving us a price of £13.50. So our choice is going to be shop A because it's going to cost less. Now part B to this question says that Harry has made the wrong assumption. He can buy single batteries, not whole packs, for 40 pence each shop A and 45 pence each in shop B. And it says, does this affect which of these shops he should buy them from? Well, you can start working out prices, but you don't need to, because of course if we are buying 30 batteries, they are going to be cheaper at 40 pence than they are at 45. So we're still going to buy our batteries from shop A, which was our original decision. So the answer is no, it doesn't. And just say why the batteries are cheaper in shop A individually. Question 16. Probability. There are only 5 blue cards, 2 green cards and 4 red cards in a pack. Isabella is going to take a random card. What is the probability that Isabella will take a blue card? Well, probability, we work it out by looking at how many blue cards there are. So if she takes a random card, there are 5 chances that she's going to take a blue one. To work out the probability, we look at how many cards there are altogether. 5 plus 2 is 7, plus 4 is 11. So the chances of her taking a blue card are 5 out of 11. And that's the probability. Part B, Ken is going to throw a biased dice once. The probability that it will land on a 6 is 0.3. What's the probability that it won't land on a 6? Well, the dice is either going to land on 6 or it isn't. Those are the only possibilities. And we know that all probabilities total 1. So, if the probability of it landing on a 6 is 0.3, then the probability of it not landing on a 6 is 0.7, because that has to add up to 1. So our answer is 0.7. Question 17 says, draw accurately an isosceles triangle with sides of length 8, 6 and 6 centimetres. And one side here. So the bottom side is 8. So we need to add in now 2 sides of 6 centimetres each. I'm going to need a ruler and I'm going to need a compass. I will say that my triangle will not look exactly like yours. I cannot on the screen here quite match the scale of the ruler to the paper. So my triangle might look a slightly different shape to yours, but the principle here is correct. We need 2 sides of 6 centimetres each. So first of all, I'm going to adjust my compass so that it is measuring just 6 centimetres. I no longer need the ruler, so let's take that out of the way. Now, with the compass, I need to put the end on the left-hand side on the very edge of my bottom edge of the triangle there. Moving slightly, there it is. I'm now going to draw a circle by doing it like this. What I now need to do is move so that my point is on the other side of the base. I'm just going to bring this round here. what I'm now going to do is draw another circle here. Now, having done that, I have a point here where the two lines have met. That point there, because of the way I've drawn it, is exactly 6 centimeters away from this edge. I know that from the first curve, and it's 6 centimeters away from this edge, and I know that from the second curve. So if I now draw straight lines from the cross here down to this edge, I have one side 6 centimeters, and the same from the same point down to the other edge, I have another side 6 centimeters. Again, be as accurate as you can, and you can leave the curves in there. It shows you working marks for the examiner. Question 18 is another graph that we're being asked to find information from. This time it's a conversion graph from dollars to pounds. So we have dollars up the side, pounds along the bottom, and we're told that Rosie bought a ring in the USA and she paid $345. We have to work out the equivalent amount in pounds. Now, the problem with this, of course, is that the scale that we've got here doesn't go up to 345. Therefore, we're going to have to do a little bit of calculation to work out the amount. I imagine there are a number of different ways you can do this. My immediate thought is to break this down. Now, 345, if I find the price for $30, so I work out the $30 price, and I do that by taking a line from $30 up to the line here very carefully and bringing it down, and it looks to me as though $30 is £23. So if $30 is £23, if I multiply all that by 10, that means that $300 would equal £230. I've simply multiplied by 10. Now that gives me $300. I want another $45. Now my graph will allow me to do this, and again I just need to be as accurate as I possibly can here. So there I've got $45, and if I move down from there I am at £35. So on top of my $300 I've got another $45. That's worked out at £35. So I come out with a total price of £265. Now there are a few ways you could do this. You could look at 10 and multiplying it up, or 60, or there are several ways. My answer of 265 is about right. I've been as careful as I can, and in fact on the answer scheme you are allowed an answer of somewhere between 258 to 275 pounds. So you do have a little bit of leeway for slight inaccuracies as you're working this out. Question 19 is telling us about the types of sandwich sold in a cafe last week: tuna, cheese, chicken, egg. It says 56 tuna sandwiches were sold, and this was 40% of the total number of sandwiches. Work out the total number. So actually we don't need the table at all. Let's have a look at this. We have 56 sandwiches sold, and this was 40%. We need to find out what 100% is, the total number of sandwiches. Therefore, this is a reverse percentage question. What we do is we start with the 56. Now we know that that is 40%. So if we divide that by 40, that gives us 1%. And once we have 1%, we can then multiply by 100, and that will give us 100%. And if you do that on a calculator, you find the answer is 140. That is the total number of sandwiches sold. Part B saying, out of the 56 sandwiches that were sold, 18 were sold on a Friday. So it wants to know what 18 is as a percentage of 56. Well, one thing we do know, we know what it is as a fraction. It's 18 out of 56. If we take the 18 and divide it by 56, the top divided by the bottom, and that gives us a decimal, which we can then multiply by 100 to find the percentage. The answer is 32.14, and it goes on and on and on. So to the nearest whole number, we are rounding it. It is 32. The next number is a 1, so it's staying as 32%. Question 20. Akhtar, Ben and Carl each have some money. Akhtar has £65, Ben has £100. Carl has 3 £5 notes, 1 £20 note and some £10 notes. We're told the mean amount of money per person is £80 and we want to know how many £10 notes Carl's got. This really is a mixed up question sent to confuse. Let's do it a step at a time. We know that Carl has 3 £5 notes, 1 £20 and some 10s, and the reason we don't know how many 10s is because we don't know how much money Carl has actually got. So we need to work that out. The clue here is the mean. The mean amount, the average amount they have each is £80. So if the average is 80 and there are 3 of them, that means in total 80 times 3 they have £240 between them. That is the total amount of money. So if we have 240 and we take away the total for Ben and Akhtar, which is the 100 and the 65, so we take away 165, that gives us a total for Carl of £75. So that is Carl's total money. Now, we know he has a £20 note and we know he has 3 5s. So that's a 20, 3 5s is 15, so that adds up to £35. In total, he has 75. We know that 35 of it is in 5s and 20s. Take that away. That must mean the other £40 must be the £10 notes. Therefore, he has 4 of them. 21A and B are about probabilities. A says Malik is going to throw a fair coin 50 times. Write down an estimate for the number of times the coin will land on heads. If it's a fair coin, it's either going to land on heads or tails. So the chances of it landing on heads is 1 out of 2. Therefore, you would expect that a half of his throws would be heads. So an estimate is a half of 50, that is 25. Now Paula and Simon are trying to find out if a different coin is biased. Paula throws it 10 times and records it. Simon throws it 100 times and records it. And the question asks us whose result will be most useful. The answer, in your own words, is Simon's. Because he has thrown it more times, he has a wider range of results. Therefore, his prediction is likely to be more accurate. Question 22, we have a shape. It's a square-based pyramid and a cube. We are told each edge of the solid has a length of 6 centimetres, and on this centimetre grid we're asked to draw the plan. So don't forget, the plan of an object is the view from immediately above. So we have to imagine we are looking straight down on top of the shape. We will therefore see a square with sides 6 centimetres. So 1, 2, 3, 4, 5, 6. And let's fill it in. 1, 2, 3, 4, 5, 6. Make it into a square. Again, be as accurate as possible. Then you have to say, what else would we see? Well, from above, we would see, imagine it's a house, we would see the roof of the house. And it would look like that. Question 23a. Simplify n to the power 3 times n to the power 5. When we are multiplying, we add the powers, therefore we get n to the power 8. Simplify for part B. C cubed d to the power 4 over c squared d. The opposite of what we did in part A. We were multiplying there, so we added the powers. Here we are dividing, therefore we are subtracting the powers. Look at the c's. C to the power 3 divided by c to the power 2. So that's 3 minus 2 is 1. We simply end up with c. Then look at the d's. We have a d to the 4 divided by d to the 1. So 4 minus 1 is d cubed. C, d cubed. Part 3, solve. 5x over 2 is greater than 7. It's an inequality. We treat it exactly the same way as an equation, but remember to keep the sign. Again, I'm going to do this by rearranging. Some people will multiply both sides. I'm going to move that 2 to the other side. At the moment, it is a divider. It's going to become a multiplier. So my next line is going to be 5x is greater than 7 times 2. So 5x is greater than 14. I'm then going to move the 5 to the other side. At the moment it's multiplying. When it gets to the other side, it's going to be dividing. X is greater than 14 over 5. Question 24. Andy cycles a distance of 30 kilometres at an average speed of 24 kilometres per hour. He then runs a distance of 12 kilometres at an average speed of 8 kilometres per hour, and we have to work out the total time and give our answer in hours and minutes. So we need to work out the two separate parts of the journey and the time for each and add them together, and of course being careful that time is not a decimal system, so using a calculator can be a little bit dangerous. Let's draw our triangle. We have distance, speed and time. So for the cycling, the distance is 30 kilometres. The average speed is 24. So to get the time, we have distance divided by speed, which is 30 divided by 24. Now if we do that, we get 1.25, and here's where we have to be careful. That is not 1 hour 25 minutes, it's 1.25 hours. How do we convert that into time? We take the decimal, the 0.25, and we multiply it by 60. And if we do that, we get 15. So our answer is actually 1 hour and 15 minutes. Let's look at the running part. So if I get rid of these numbers, for the running part, he runs a distance, we now have 12 kilometres, and we have a speed of 8 kilometres per hour. So for the time, again, it's 12 divided by 8. And if we do that, we get 1.5 hours. Now 1.5 is a little bit easy. We can do the same. We can multiply the 0.5 by 60. But 1.5, that's 1.5. So 1.5 hours is 1 hour and 30 minutes. If we add the two times together, we have got 2 hours and 45 minutes. And that's our answer. Question 25. A number m is rounded to 1 decimal place, and the result is 9.4. It says complete the error interval for m. So if we have a result of 9.4, what we are looking for is the lowest possible number that would round to 9.4 and the highest possible number. Well, using the rules of rounding, if we had 9.35 and rounded up, that would be 9.4. Anything below 9.35 would round down to 9.3. So 9.35 is our lower interval. Above, well, technically, the highest number that will be rounded down to 9.4 is 9.499999 recurring. So what we do is we call it 9.45. So the answer is 9.45. Question 26, Part A. Maisie knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 meters by 9 meters. She can buy grass seed in 2 kilogram boxes. Maisie wants to make a rectangular lawn 10 meters by 14, and she has 5 boxes of grass seed. Has she got enough? Let's have a look at this. Well, the first bit of information we have is this rectangular lawn is 9 meters by 5 meters. So 9 times 5, or 5 times 9, equals 45 meters squared. To cover that, we know that she needs 3 kilograms of grass seed. So if we take the 45 square meters and we divide that by 3, it means that 1 kilogram of grass seed equals 15 meters squared. We can use that for the second part here. We now have a lawn which is 10 meters by 14. So 10 times 14 equals 140 meters squared. We know that 1 kilogram is 15 meters squared. We need to work out how many kilograms we need for 140 meters. So 140 divided by 15 is 9.3 recurring. In other words, to cover the lawn 140 meters squared, she needs just over 9 kilograms of grass seed. So it's sold in 2 kilogram boxes and she has 5 of them. So she has 2 times 5. She has 10 kilograms. She needs 9.3. So yes, she has sufficient. And this question has a part B. It says that Maisie opens the 5 boxes of grass seed and finds that 4 of them do contain 2 kilograms of grass seed, but the other box only has 1 kilogram in there. And it says, does this affect whether Maisie has enough grass seed? Well, we know from part A that she needs 9.3, and it was 9.3 recurring kilograms of grass seed. Now she has got 2 bags of 4, that's 2 times 4 is 8, plus the last bag only has 1 kilogram, she only has 9 kilograms. So in fact, she's short. So the answer is yes, it does make a difference. Now she doesn't have enough grass seed. Question 27. Amanda has 2 fair 3-sided spinners, spinner A, spinner B. She spins each spinner once and we have to complete the probability tree diagram. So the first part is spinner A. We are looking for the top root here as the probability that it's going to land on 2. Well, there are 3 sides. It is a fair spinner, therefore 1 side out of 3 is the chance that it's going to land on the number 2. It's got 3 sides, one of them is 2. The probability that it doesn't land on 2, well, if it doesn't land on 2, it's going to land on 1 or 3. So it's got 2 options out of 3 that it's not going to land on 2. Spinner B. The probability that it lands on 2 is exactly the same. It is 1 side out of the 3. And the probability that it does not land on 2 is 2 out of 3. Spinner B is the same on the bottom half of the tree here. The probabilities are not changing. So the probability that it lands on 2 is 1 out of 3. And that it doesn't land on 2 is 2 out of 3. So that completes the probability tree for the first part of the question. Now part B says work out that the probability that spinner A lands on 2 and spinner B does not land on 2. Well, the probability of A landing on 2 is 1/3 and the probability of B not landing on 2 is 2/3. So to calculate the total probability, we have to multiply those 2 fractions together. So it's 1/3 multiplied by 2/3. We multiply across the top. 1 times 2 is 2, and across the bottom 3 times 3 is 9. So that's the answer to part B. Question 28 also has 2 parts, but they apply to different graphs. So let's look at part A first. Use these graphs to solve the simultaneous equation. 5x minus 9y equals minus 46. And if we look at the graph, that is represented by the line here. Y equals minus 2x is represented by the second line. Solving a simultaneous equation means we have to find values for x and y where they are equal for the 2 different equations. Now, you can do this with an awful lot of algebra, but in fact when you have a graph with the lines drawn out, all you need to do is to look at the point where they meet. because that point on both lines, the coordinate of x and the coordinate of y is the same. So all we have to do is read that point as a coordinate. X is -2 and y is 4. And part B of question 28 is another graph. This time it is asking us to use the graph to find estimates for the solutions of the quadratic equation x squared minus 4x plus 2 equals 0. Again, it is perfectly possible to use algebra to calculate the value of x here, but again, when it's drawn on a graph, we can use the graph. Now this time, the 2 points we are looking for, well, it says equals to 0 here, so what we look at is the line y equals 0, in other words, the x-axis, and we look at the 2 points where the graph crosses the axis there. All we need to do is read out the values of x for these 2 points. And again, be as accurate as you can. I am looking here and it looks to me that's 0.5. I would say that was 0.6. And the second one, 3.1, 2, 3, 4, I would say that is 3.4. So those are the 2 solutions for the quadratic equation. And finally, we have question 29. The diagram shows a solid triangular prism. The prism is made from wood and it has a density of 0.8 grams per centimetre cubed. We need to work out the mass of the prism. It's another of the triangles, the ones that we have to remember. This time the letters are mass, density and volume. So we are working out the mass. We need the mass. In order to do that then, we need density multiplied by the volume. We know the density, therefore our first job is to work out the volume. So, volume of a prism. First of all, we work out the area of the cross section here. Now this is a right angled triangle, so the area of a triangle is the base times the height divided by 2. So 4 times 6 is 24, divided by 2 equals 12 centimetres squared. Once we have that area, we multiply by the length, that gives us the volume. So that's 12 times 10 equals 120 centimetres cubed. We now have density and volume. So density is 0.8 grams per centimetre cubed and the volume is 120. So 0.8 times 120 equals 96 grams. And that's the end of the paper. I do hope you found that useful. Please feel free to put your comments in the bottom of the video here. And if you do subscribe, I do try to bring out videos regularly, and there may be something else on my channel that might be of use to you. Most important of all, good luck in your studies. Thank you for watching.